Good day, students and viewers. My name is Abdulazeez Idris, your regular Start 132 lecturer. In today's video's lecture, we are going to talk about the binomial distribution. And so, if you are given that the probability of an event occurring in a single trial is given as P, that's the probability of an event occurring is given as P in a single trial, and the probability of failure is given as Q, then clearly the probability of success, the probability of failure is always equals to 1. That is a fact. In our previous lectures, we have ascertained that. And the probability of an event, that an event occurs exactly X times in N independent trials is given by, so the probability distribution is going to be P of X is equal to N combination X, P raised power of X, Q raised power of N minus X, where N combination X is equals to N factorial over N minus X factorial and then X factorial. This is a combinatorial formula already basically known by at least 100 level students of any university. So where X is equals to, and the value of X can range from 0, 1, 2, in that order, up to N. So X ranges from 0 to N. So X can be equals to 0, it can be equals to 1, 2, 3, up to the last trial, which is equals to N, the nth trial. It is clear that N factorial is equals to N times N minus 1 times N minus 2 times N minus 3 times up to, 3, 2 times 1. And this is the meaning of N factorial. So we start by taking an example. The example here is saying, let the probability, the example here is saying, what is the probability of obtaining exactly 4 heads in 6 tosses of a fair coin? This is the EG. What is the probability of obtaining exactly 4 heads exactly 4 heads in 6 tosses of a fair coin. So the probability is going to be given by the probability distribution function, which is, we know it is clear that from the formula P of X is equals to probability of X occurring exactly X times is going to be equals to N combination X, P raised power of X times Q raised power of N minus X. Now we are to determine our X, our N, and our P and Q respectively. Now, in this problem, we are given that the probability of obtaining exactly 4 heads in 6 tosses of a fair coin. So here, 6 tosses, N is equals to 6. And exactly how many heads? 4 heads. So our X is equals to 4. And then the probability of obtaining a head in each trial, because a coin has 2 faces, therefore is either a head or a tail. So obtaining a head, the probability of obtaining a head is always 1/2. Because it has 2 faces, either a head show up or a tail show up. And therefore, this is going to be 1/2. But to get the probability of failure, which is Q, we just say 1 minus P is equals to our Q. Therefore, our Q is going to be 1 minus 1 over 2, and that is equals to our Q. It means our Q is equals to 1 over 2, because 1 minus half is equals to half. So Q is equals to half, as well as P equals to half. Therefore, we have our value for N, for X, for P, and for Q. We can just go ahead and substitute in the formula and get the required exact probability we are asked to find. Therefore, the probability of 4, because x is equals to 4, of course, I'm using the direct value of 4 of x. So we have 6 combination 4 times 1 over 2, because that is p, rest power of x is 4, and then times q, which is equals to also 1 over 2, rest power of 6 minus 4, which is equals to 2. That is equals to n combination 6. 6 combination 4 is going to be, this is going to be 6 factorial over 6 minus 4 factorial, 4 factorial times, this is going to be 1 over 2 raised power of 4. 2 raised power of 4, this is equals to 2 raised power of 4. I think this is equals to 2 times 2 times 2, and that is equals to 16 times, this is 4 minus is 2. Therefore, this is 1 over 2 raised power 2, which is equals to 4. But this is equals to 6 times 5 times 4 factorial over 2 factorial, because 6 minus 4 is 2, of course, and then divided by 4 factorial. So 4 factorial will cancel 4 factorial. All I have is, this is times 1 over 16 times 1 over 4. And this is equal to 6 times 5, the answer is 30, and then divide by 2, which is equals to 15. So I have 15 times 1 over 16 times 1 over 4. And that's equals to 15 over 16 times 4. And that is equals to 64. 64. So this is the probability, exact probability for tossing a fair coin 6 times, and the desired x is 4. Obtaining heads 4 times is the exact probability. Thank you for watching.